The temperature of a coffee in a cup. Look at the first question, please.
Mhm.
Yes. The temperature of coffee in a cup at time t minutes is modeled by the decreasing differentiable function. Decreasing, C is decreasing differentiable function. Ct measure degree in Celsius for time t equals 0 to 12. Selected values of Ct are given in the table as shown. These are the values given to you. The question is you need to approximate the derivative at 5. Uh, on the first question is it's an easy task for you how to because table is given to you no exact formula but 5 lies somewhere in between here between 3 and
Yeah,
5,
correct.
right? So
So
if
this
you
should be
ask
easy
me,
now. If
yes,
we
if you ask
you
me
just
to
find
find
like
out
yeah,
C for prime 5, I cannot tell you exactly, but yes, for approximation, I will be using like the rate of change around 5, that is C5 minus C3 divide by 7 minus 3, it is 69 minus 85 divide by 4. What is the answer, please? Minus 4, perfectly okay. So it
so
is
easy.
minus
Yeah.
4 degree. Unit is going to be Celsius per time is in minutes, Celsius per minute.
Okay. ठीक है.
Okay, reason being the numerator is Celsius, degree Celsius, and the denominator is going to be time there. So it is Celsius per minute.
Correct. Yeah.
You say degree Celsius per minute. This is going to be the unit. Because it
अच्छा.
is using the word left Riemann sum, I'll tell you how to deal with it. So just suppose you need to find that integral 0 to 12 ct dt. So left Riemann sum will be whatever the interval, whatever the division you are having, length of the interval, like there are 4 intervals if you see. First, 0 to 3, second, oh sorry, there are 3 intervals basically. So for every interval like 0 to 3, what is the length of the interval? Multiply the value of the function. Function is ct for you. And because it is left Riemann sum, I'm going to multiply by the left hand side. First value is going to be multiplied by 100 for the first interval.
Correct.
For the first interval, I'm choosing 100. This is the left value out of these two, right? For the second interval, like from 3 to 7, the interval difference is going to be 7 minus 3 multiplied by, out of these two, 85 is 69, 85 is the left hand side value. Next, out of 12, 12 minus 7 multiplied by uh, 69. This is the left Riemann sum. Okay, just
Hmm.
calculate the value and you will be getting the answer. And then after they're asking you what is 1 over 12 integration 0 to 12 ct.
Average value.
This is the average, yes.
Hmm.
Average of ct in the interval 0 to 12. That is all. Is it difficult? Yes, C part. So for time t equals for time t from 12 to 20, the rate of change of the coffee is modeled by the C prime t, where C prime t is measured in degrees Celsius per minute. Find the temperature of the coffee at time t equals 20 there and show the steps of your calculation.
Hmm.
Okay. According
So
to the table, you know what is going to be the temperature at 12. Am I right? What was given to you? 55 degree.
right.
So this is given to you. And I'm looking for C20. This is the question. And during this, I know how the rate of change behaves. So
So
it is a
20 to
simple
12
task now.
integral.
Yes, I need to integrate 12 to 20 this C prime t
Correct.
dt. This is going to be C20, sorry, C20 minus C12. Okay, so just try to substitute the values and integrate. You can use your calculator to get the answers. It is negative 24.55 e exponent 0.01 t divide by t dt. This is C20 minus C12 was how much? 55. So can you use your calculator or should I use the calculator?
Wait, give me 1 second. Uh,
This should be the answer. This is what I told you. Whatever the value of this integral, you need to substitute here. Use your calculator to find this value. So let us go to the D part. For the model definition in part C, uh, it can be shown that the double derivative is given to you for time 12 to 20. Determine whether the temperature of the coffee is changing at a decreasing rate or at an increasing rate and give your reasons basically. So it's an easy task for you. Like what is CT? CT is representing basically temperature of the coffee and it is decreasing. This is what we know. Okay. We find the CT, that means the rate of change, instantaneous rate of change at any point. C double derivative of T is measuring the rate of change of C prime. Am I right? What it
hmm,
is representing the rate of change of C prime basically. So in case if it is positive, then C prime T, the rate of change is going to be basically increasing. And if it is less than 0, then C prime T is decreasing. Simply, this is the meaning of the expression. Am I right? So, because C double prime is given to you, I need to only check if it is positive or negative, or what are the intervals where it is positive or negative. So now, if you look at the double derivative given to you, let us just talk about the variables given to you. 0.244, it is a constant. I don't uh, just, it is a constant only. No sign is required. E to the power, whatever given to you, this is going to be always positive term. This is going to be always positive. And then 100 minus t divided by t square. Only these two terms will be governing the governing the sign of the double derivative. So these two will not govern anything. Now just have a look. 100 minus t, this is going to be positive for any value of t in between 12 or 20. Am I right? Any doubt?
no.
And the denominator t square, it is also positive. That means to say that for this particular double derivative, this double derivative ct is 0 for all time t from 12 to 20. Yes, and that means to say that the rate of change is increasing. Change is at an increasing rate. Did you get the task? We only try to find out the sign of the double derivative. So you check constant is positive without any issue. E to the power anything is positive. Only 100 minus t over t square need to be checked. During the interval, 100 minus t is always positive and t square is always positive. So overall, the sign of the double derivative is positive. So whenever the sign of double derivative is positive, then c prime t is increasing rate. Okay,
Hmm,
so that is the answer.
okay.
The rate of change of c prime is at increasing rate. That is all. Done?
Yeah.
Yes. A particle moving along a curve in xy plane has the position xt yt at time t seconds. Okay, where xt and yt are measured in centimeters. It is known as the derivatives given to you at time t equals to 2 second. At time t equals to 2 second, you have the situation. The position is given to you like 3 6. Find the speed. Okay. And whenever the parametric equations are given to you, and if I ask you about the speed, say, let me assume it to be Vt. It is going to be square root of x prime t square plus y prime t square. This is going to be your speed.
Hmm.
Any doubt? So you need to simply plug the values, and then after put t equals 2 there, it is 8t minus t square whole square plus minus t plus square root of this t exponent 1.2 plus 20 this whole square, and you need to find the value at 2. You need to evaluate this expression, and that is all. Will you be able to get this value?
Yeah. Yeah. Give me a second.
SQRT. Square root of bracket is started. This is 8 t minus t square whole square plus minus t plus square root. It is t exponent 1.2 plus 20. And now I need the value of f at 2. It is 12
Yeah.
point something. So this is the first part. Is it difficult? The
No.
second part is also easy. You need to find the total distance covered. The total distance covered can be obtained using the expression.
Integral.
Yes, you need to simply integrate from 0 to 2 and vtt. Okay, so 0 to 2 I don't have any issue. V2 is this integral part, and then after dt. Am I right? And again, we are going to use the calculator for this part also. Yes. So this time integrate from 0. Let me just show you the working to this ft dt. The value is coming out to be how much? 15 point something something. Okay. So simply using the calculator, you should be able to get the answers. So find the y coordinate of the position of the particle at time t equals to 0. Show the setup of your calculation. Okay, setup is not a big task for you. The initial conditions given to you was at time t equals 2, the position was xy. I should use the word x2, y2. It was given to you how much? It was 3 and 6. And y prime is given to you. What is y prime? It is negative t plus square root of this t exponent 1.2 plus 20. So that means to say that if I integrate from 0 to 2 y prime t dt, I should be able to get y2 minus y0. Am I right?
Yeah.
y0 is 6 for y2 is 6 for you. That means y0 is going to be y2 is 6 minus integral from 0 to 2 y prime t dt. Use the calculator to get this value. I hope you will be able to get the answer.
Yeah.
Okay, just
Wait,
give me a
actually, I'm sorry.
second,
Can I see your work again? Sorry, can I see your work?
please.
Yeah.
Can we use the calculator to get the value of this expression?
Sure.
So I'm going to integrate from 0 to this expression dt, and give me a second. Minus 6 minus. Okay, I need to. It is 6 minus. The answer is like 1 point something something. So this is the answer I'm getting. Can you please check? Give any doubt?
No.
Perfectly. Okay. So this is going to be the C part for you. Let us talk about the D part now. Just read the question for the D part. For time t from 2 to 8, the particle remains in the first quadrant. For all times t in the interval 2 to 8, when the particle is moving towards the x-axis, give a reason for your answer. Okay. When the particle is going to move towards the x-axis, see what they told you from the time 2 to 8, the particle remains in the first quadrant. Okay. For the particle, you are having two values, xt and yt. The question is, for all time t, the particle is moving towards the x-axis. This is what they're telling you. Am I right? This is the moment. That means the
Hmm.
height is decreasing. Height decreasing stand for derivative of t is going to be less than 0. Any doubt? Height is
Let me.
decreasing.
Yeah.
Okay, because we are in the first quadrant. This is the first quadrant you will be having, and you are moving towards the x-axis. This is only possible when the yt is going to be decreasing.
Oh, wait.
So
So it's only possible when y decreasing?
yes,
Gotcha.
okay, and additionally, because you're in the first quadrant, your yt should be positive, and your xt should be positive. So this is the reason why you should be in the first quadrant. Okay, and this is the reasoning why you should go towards closer to the x-axis. Any doubt? So now let us just get the values again. I don't have xt and yt, but yes, we can talk about derivative y prime t. This is the initial condition, initial information given to you. For y prime t, can we check if from 2 to 8, if we are able to get the derivative negative? I need to find out the points where the derivative is changing the sign. Once I know that derivative changing the sign, then I can tell you whether during which interval approximately it is increasing or decreasing. For this, I wish to use the sign, the graph of it. I think that is a best way to check the situation here. So let me just consider y equals this value during the interval 2 to 12. Cancel. Give me a second, please. Okay, you need to find all times. Okay, the question is you need to find all times where the function is moving towards the x-axis. Am I right? That is good. Check. Did you get the graph?
This graph, yeah.
If the graph is there, so you can identify the points. Let me just paste the graph, and you can identify the points that during 2 to this interval, open interval, you should not take the end point. The derivative was positive. That means the height is increasing. That means height is increasing. And from this interval to 8, the derivative is negative. That means the height is decreasing. So the question was find all points. You need to find all points in the time interval. So the all points are going to be the points from starting point 5 open interval 5.22183, and it will go up to 8 there. These are the points where the particle will be moving towards the x-axis. Any doubt? Okay. Now we have moved toward no calculator is allowed. So that means you need to do some kind of calculations without any issue.
Right.
This is going to be number 3 there. Read the question. Meanwhile, I'll paste the gradient curve. The depth of seawater at a
Mm-hmm.
location can be modeled by the function h that satisfy the differential equation dh over dt given to you, where ht is measured in feet, t is measured in hours after noon. Time t equals to 0. Afternoon, that means it is starting from 12 o'clock. It is known that h0 is 4. 0 maybe stands for the 12 hours. Okay, and t is time in hours, h0 is 4 there. Perfectly okay. A part is a portion of the slope field for the differential equation is provided. Sketch the solution curve. So that means they have already told you the position was 4 in the beginning. So you need to just follow the field there. Sorry. And I hope this type of solution will be there. Can you please check? Just you need to make use of the slope field.
Right.
No issues?
Yeah.
Perfectly okay. Let us just try to find the B part. So for time t equals t from 0 to 5, it can be shown that ht is bigger than 1, height is bigger than 1. Find the value of t for 0 to 5, at which h has a critical point. Determine whether the critical point corresponds to a relative maxima, relative minima. Okay, so basically we need to find the critical point, and the critical points can be obtained if you put the derivative equals to 0. Am I right? So they have given you, there are two observations given to you. First observation is during the interval 0 to 5, ht is always bigger than 1. Second observation is dh over dt is with you. It is h minus 1 cos t by 2. Using this, you need to find the critical points. And finding the critical points, just suppose you are having a local minima, local maxima. Local maxima can be obtained if the change of sign of the derivative is from positive to negative during a critical point C. I'm telling you again, if the sign of dh over dt is moving from positive to negative, then you will be having a relative maxima. And if it is like this, that is sign is changing from negative to positive, you will be getting relative minimum. So you need to observe just the curve, and using the curve, you can tell me what is the situation there. So I need the graph basically, graph of the derivative. See, your h minus 1 in this term h minus 1, it is always positive. So dh over dt will be, see, there are two terms given to you. So I will not be focusing on this term. I will only focus on cos t by 2 only. And I will look at the point between the interval 0 to 5 there. So this is 0. So if you look at the points where the dh over dt is 0, these are the points you will be getting. Check. Because it is given to you that ht is always bigger than 1. So this term is always positive. So if you plug dh over dt equals 0, that will make it like cos t by 2 equals 0. And the only point you will be getting will be pi there. Any doubt? Is there
No.
any doubt? Perfectly okay. So pi is the only point what I'm getting here, because and pi lies between 0 to 5 there. Other point is 3 pi, that is going to be beyond 5. So the only critical point I'm able to find is pi there. Now can you please check the graph? This is basically cos t by 2. Cos t by 2 is positive on the left hand side, negative on the right hand side of pi. Can you please check? This is the graph of cos t by 2.
Right.
So I can use this graph. That means to say that dh over dt change sign from positive to negative to negative. Whenever there is a change in sign from positive to negative, that means I am in this position. From positive to negative, I will be having a relative maxima. So that means you will be having a relative maxima.
Hmm.
Relative maxima. Any doubt?
No.
That is all. So this part is done. Use of separation of variable to find y equals st, the particular solution to the differential equation with the initial condition s0 equals to 4. Separation of variable stands for dh divided by h minus 1 is going to be 1 by 2 cos t by 2 dt. Okay, so this is the first step. And the initial condition for you is like it is given to you at time t equals 0. Your ht is 4. This is given to you. So I'm going to integrate. I'm going to integrate from 0 to t there. Okay, not 0 to 2. So let us not integrate like this. Otherwise, there will be issues. Simply integration. Is it going to be ln h minus 1? The left hand side, right? Can you
Hmm.
please help me with the integration of the this side? Is it going to be sine t by 2
Yeah.
plus c? Just have a look at the
We know. I think
calculation. If
what would it not be a 2 sine t by 2?
this 1 by 2 will cancel out
Oh
that
yeah,
2.
yeah, yeah, yeah.
Okay, I hope so. Yes, yes, there is no issues. Perfectly okay. And if you wish, you can put the mode there, but I don't think it is required. But yes, you can put the mode. This is going to be the solution. I need to find the value of c there. So for this, I will use the condition given to you at time t equals to 0. H was 4. So you just plug the values here. Ln, this is 4 minus 1 is going to be sine 0. Sine 0 is 0 for you. The value of c is going to be ln 3, right? So
Hmm.
therefore, the solution is going to be, because h, the height is always bigger than 1. This is what given to us in previous part B. So I'm using this h minus 1 only. Constant c I'm transferring on the left hand side. This is sine t by 2 This is going to be ln h minus 1 divided by 3 is sine t by 2. This is going to be h minus 1 divided by 3 is e exponent sine t by 2. And the value of h is going to be 1 plus 3 times e to the power sine t by 2. Any doubt?
Hmm.
So there are only three parts we did. That is all the three parts. Question number 3 is done. The graph of the differentiable function f from the interval -6 to 7 has a horizontal tangent at x equals -2. You will be having a horizontal tangent and is linear for 0 to and it and is linear for 0, 7. R be the region in the second quadrant bounded by the graph of f, the vertical line x equals to -6 and x-axis y-axis. R has the area 12. This area is given to you 12 there. They defined a function gx from 0 to x ft dt. They need g minus 6. So the first question is easy task for you. G minus 6 stands for integration from 0 to -6 ft dt, right? This can be written as 0 -6 to 0 ft dt. This term is given to you 12, like the area of the region. It is given to you 12. So the first answer is -12.
-12,
And
yeah.
okay, the graph is linear. So from 0 to 7, this is a straight line. It is a linear. So now
Hmm.
I get it.
So no, it's saying what GF4. So GF4 का मतलब what 4 to 0 or 4 to
0
0
to, no, no,
simply
0 to
4
4,
into
0
2
to
to
4, 0 to 4,
oh sorry हाँ I keep saying 4 to 0 क्योंकि पहला वाला 4 होता है दूसरा वाला
1, 2,
0
3,
होता है
4.
but हाँ
Yes.
right but it's
The
going to be
basis
4.
for height is 2. Yes, perfectly okay. And G6 is required. It's not a big task to get the value of G6. Okay. So G6 can be like 4 for the first one, negative. This is going to be 1 by 2, 2 and 1. That is simply 1. I hope it is going to be 3. It is not a big task for you, right?
Okay.
So it's an easy task for you. The B part, let us try to do the B part. Yes. For the function g defined in part A, find all values of x in the interval 0 to 6, at which the graph of g has a critical point and give a reason. That's an easy task for you. Critical point stand for the derivative of x is 0.
Yeah.
That means derivative of this 0 to x ft dt is 0. Simply that means fx is 0 and fx x is 0 only at one point. What was that point? This is 4 there. This is 4. So the critical point is going to be 4 for you. Any doubt?
No.
Perfectly okay. This is the last question should we do? Last part C maybe. Yes. Then after there will be next question. So let us just do up to this point. The function h is given to you. Find the value of h6, h prime 6, h double prime 6. Okay. This first question is h6. H6 is going to be how much? -6 to 6. This f prime t dt, which is nothing but your f6 minus f minus 6. Am I right?
Yeah.
F6 was 0. Sorry, f6 was -1 and f minus 6 is 0.05. So if you ask me the value, I will tell you -1 minus, I think it was positive 0.5. It is negative 0.5. Do you agree? Have I made any mistake? Oh, it is negative 1 point. It should be. It should be 1.5, negative 1.5. Can you please check? Look at the values again. -1 and 0.5. So -1 minus 0.5, this is what the value of H6. Second value, you need the derivative. Derivative is nothing but f prime t, f prime x, sorry, f prime x. So derivative at 6 is going to be value of function at 6, because it is linear to you, because the graph is linear to you. At 6, I need the slope of this line. That is going to be the answer. So if it is passing through the point 0, 4 and 6 minus 1, and if I ask you the slope, that is f prime 6 for you, y2 minus y1 divided by x2 minus x1, it is negative 5 by 6. It is negative. Oh, can you please check if I have made any mistake? Yes, I made lots of mistakes there.
Oh,
I made lots of mistakes there. Give me a second. The mistakes are, the point was 40. Now, if you find the slope there with the negative sign, it is going to be y2 minus y1, that is -1, -0, divide by 6 minus 4. It is -1 by 2. So that was a mistake. It is going to be 1 by 2. And then after, you need the double derivative at x, that is the derivative. Any doubt? And I need double derivative at 6. Now, because function is linear there, function is linear nearby 6 there, the double derivative of that function is going to be 0. The first derivative is a constant term, the second derivative is going to be 0. These are the values. Any doubt?
clear.
Clear? So let us stop here. There are two more questions left. I request you please try those two questions. And if there is an issue, we can discuss them.